Shoo-ba-doo-ba-doo, bam-ba, lim-ba-loo-doo-doo-doo-doo-doo-doo-ba-da, doo-doo-doo-doo-doo-doo-doo-doo-doo-doo-doo.
What if 3 simple rules explained almost every movement around you? Just think about it. A skateboard rolling down the street, a rocket launching into space, even while you fly forward when a car comes to a sudden abrupt stop. These are Newton's laws of motion, and actually they changed humanity forever. Because before Isaac Newton, humans understood movement, well, badly. For thousands of years, people thought objects naturally stopped moving unless something constantly pushed them, which kind of makes sense if you think about it. Like, you kick a ball, it slows down, maybe even stop at some point. Not maybe, definitely. Same thing happens when you push a car. Eventually, it stops, right? No matter how smooth the surface. But Newton realized something massive. Objects aren't stopping because motion simply dies. No, they stop because forces like friction and air resistance are constantly interfering, and that leads to Newton's first law of motion. Object in motion always stays in motion, and an object at rest always stays at rest, unless acted upon by another force. Here's an example. This water bottle here, it's gonna be in motion in just a few seconds. It was just in motion, you see that? But wait a sec. You see, I threw this water bottle, and it was just acted upon by another force, therefore causing it to stop moving altogether. Very interesting, right? And right now, this water bottle is completely at rest. But I'ma move it. I'm a different force acting upon it. Dang it, I thought I was gonna get it. Anyways, that tendency is called inertia. And inertia is absolutely everywhere. When a car suddenly brakes and your body jerks forward, that's inertia. Pretty sure you remember that example from earlier on in the video. Your body was moving at the same exact speed as the car. You and the car are moving at the same time. And when the car stops, your body just flies forward. That's why seatbelts matter so much, because they stop your body from flying straight through the window. Or just think about the tablecloth trick. You just quickly yank out the tablecloth trick, right? And the dishes barely even move, if they even move at all, because the plates want to stay where they are. The plates don't want to move, right? Now, that sounds simple, like right now, right here, today. But back then, back in Newton's time, this idea completely changed physics. And it becomes even crazier in space. Wait, we're going to space? Imagine sliding a hockey puck across perfectly frictionless ice. It would travel way farther than normal for sure, but it would still stop at one point because there's air resistance. But now, remove the ice entirely. Remove the air. Remove friction altogether. The puck would just keep on moving. It wouldn't stop. It would just move forever. No engine needed, no constant push, just motion continuing endlessly through space. Earth isn't being constantly pushed, right? It's just already moving, right? That's why planets move around the sun, because there's absolutely no air. There's nothing to stop it. There's no friction, nothing, right? And it's the gravity that actually bends the direction of Earth around the sun. And Newton's first law actually helped humans understand that motion itself is natural. But then comes the second law, the one that explains how motion changes. Newton realized that force, mass, and acceleration are all connected. F equals ma. Force equals mass times acceleration. Tiny equation, huge effects, huge differences, huge everything, right? Basically, the more force you apply, the more something accelerates. Because the more mass something has, the harder it is to accelerate. That's why kicking a soccer ball is easy, but kicking a car is a terrible strategy. I'm like, come on. You'd have to be really stupid to kick a car to make it move. Be honest, did you kick a car to make it move? Yeah, exactly. No one is stupid enough, right? The car has way more mass, and this law governs almost everything engineers build. Cars, roller coasters, airplanes, bridges, sports equipment, even rocket. Think about launching a rocket into orbit. That rocket is insanely heavy, so if you want it to accelerate upward fast enough to escape Earth's gravity, you need an absurd amount of force. That's why rockets produce gigantic explosions of energy to leave the ground, just to leave the ground, right? And Newton's second law lets engineers calculate exactly how much force is needed. Too little force, the rocket fails. Too much stress, parts break apart. Hey, parts and apart, that's funny. The entire modern world quietly depends on this equation working perfectly. Perfectly. Now, Newton's third law of motion. Woohoo! Probably the most famous one, actually. For every action, there's an equal and opposite reaction. You push on something, that something pushes back on you. When you walk, your feet push backwards against the earth, and the earth pushes you forward. When a swimmer pushes water backward, the water pushes the swimmer forward. In rockets, this is where it gets really weird. A rocket pushes hot exhaust gases downward at incredible speed, and the gases push the rocket upward with equal force, and that means that the rockets do not need air to work. That's one of the biggest science misconceptions ever. People sometimes imagine rockets pushing against the atmosphere. Like, does that make sense? Alright, well, let's dig deeper. Space has almost no atmosphere, right? And a rocket works because of Newton's third law, not because it's pushing against the air. And honestly, it still feels kind of fake, because your brain expects movement to need something solid to push on, but the rockets carry both sides of the interaction with them. The rocket and the exhaust push one way, move the other way. And these three laws together became the foundation of physics. Published in 1687, by the way. Just think about how crazy that timing is. This was before electricity, before cars, before airplanes, before computers, before modern factories even. Yet, Newton created rules so accurate that centuries later, scientists globally still use them to launch satellites and send probes across the solar system. NASA calculations still rely on Newtonian mechanics every single day, even though modern physics eventually discovered relativity and quantum mechanics, and Newton's laws still work incredibly for everyday life, which is kind of unbelievable. 3 laws, few pages of math, and suddenly humanity could predict motion, not just here on Earth, but across the entire universe itself. And there you have Newton's 3 laws of motion. And this has been Yusuf Muhammad Abulaiz. Over and out.